Hello and welcome back to our series on electrical and computer engineering. Tonight we're going to talk about electric circuits and topology. Topology, according to Wikipedia, is an area of mathematics that deals with shapes, and in particular with the properties of those shapes that will not change if we shrink, fold, or stretch that shape. Those properties are called invariants of the shape. Our task tonight is to identify the invariants of an electronic circuit. And to do that better we will make abstraction of the blocks and that are inductors and resistors and capacitors. When we do that, an electric circuit looks pretty much like a Fisherman's network. And in that network, like this one, we can identify immediately those invariant properties. The knots and the threads that join the knots. Two properties. Now, when we take those two properties, knots, which are points in the Fisherman's net, where three or more threads come together, and the threads are paths that join two knots together, we find ourselves with the proper invariance of our circuits. If we fold the circuit, if we stretch it, if we shrink it, those knots and those threads will remain. They keep their identity. And that is how we do. But in electronics, we have changed those names. Instead of calling that a knot, we use a fancier word that has exactly the same meaning, node, which means exactly that, node, nodal, a knot. And the threads, those paths that join two knots, two nodes, mind you, we will call branches. So this is a branch, and that is a branch too. Observe, this branch has two elements. This branch has only one element, but they are both branches because they join this node to this node, in this case, and this node to the other node. And you're thinking, what about this one? In high school, we identify that as a node also. Well, yes and no. That is also a node, but it's a very particular and very special type of node. That is a repaired knot in the Fisherman's net. We call that in electronics a binary node or a B node. A B node has a very special place in electric circuit theory, but the ones we will be using all the time and will be writing equations for are the true nodes. These ones where we have three or more branches arriving at it. One comment, a node includes not only the point where the three branches come together, or four or five, but also the wires that join them in the electronic circuit. Observe. Here we have the join of three branches. But the wires that spread from there are also part of the same node. So you have one node and we have 1, 2, 3, 4, 5, 6 different branches arriving in that node. Let's see if we have communicated. I will show you a circuit and you will tell me how many nodes you see there, how many branches you find, how many binary nodes you can count. Let's proceed.